When we watch the final miles of a marathon, we really tend to romanticize the whole struggle.
Oh, absolutely. We see the grimacing faces and the heavy legs.
Right, they're practically dragging themselves toward the finish line, and we think, it's all about willpower. We tell ourselves this great story about the human spirit.
Yeah, we think, like, wow, they just have so much heart. They just want it more than the person behind them.
Exactly.
But, I mean, it is entirely human to do that. We turn a purely physiological event into, well, a psychological drama.
We really do.
We frame it as mind over matter, as if grit alone is propelling them forward.
But if you actually strip away the inspirational music and the cheering crowds, what you are really watching is just a brutal, unforgiving cascade of cellular failures.
Yeah, that's a good way to put it.
It isn't poetry, it's plumbing. It is just this harsh equation of supply and demand happening at a microscopic level.
It's literally the biological reality of an engine that is fundamentally running out of fuel and failing to clear its own exhaust. And the rules governing that engine are entirely rigid. I mean, you simply cannot outwill a lack of oxygen in a muscle cell.
Welcome to today's deep dive. Our mission today is to completely deconstruct the engine of human endurance for you.
Yeah.
We are going to look at the exact physiological limits of the human body, how we have historically managed to measure them out in the real world, and then, this is the crazy part, we are going to unpack a groundbreaking 2022 study.
A really incredible study.
Yeah, a study that completely flips our understanding of male versus female athletic performance.
We have a really fascinating stack of research to guide us today, too.
You really do.
We are pulling from a historical breakdown of the infamous Cooper test from Wikipedia, a deep physiological analysis on the limits of endurance from the University of New Mexico, and that truly revolutionary 2022 study published in Frontiers in Physiology.
Okay, let's unpack this. The core premise here is that whether you are a world-class marathoner gliding across the finish line, or, you are just a recreational runner trying to jog around the block without wheezing.
Which is most of us.
Right, exactly. But your body is facing the exact same biological bottlenecks. The constraints do not change. Only your specific capacity does.
And our goal today isn't just to list what those constraints are. We really want to understand why our bodies are built that way.
Yeah.
Like, what is physically happening under the hood when your brain is just screaming at you to stop?
To even begin talking about the biological limits of human endurance, we run into an immediate problem.
Right, the measurement issue.
Exactly. How do you measure something that complex without hooking everyone up to expensive laboratory equipment? That question leads us to the creation of what I like to call the 12-minute torture test.
Which is otherwise known as the Cooper test.
The Cooper test.
If you have ever been involved in organized sports or the military, just hearing that name probably induces a mild stress response.
I bet it does.
It was created back in 1968 by a physician named Dr. Kenneth H. Cooper.
I was looking at the history of this, and the origin story is wild. This wasn't just some gym teacher's idea for a high school PE class.
No, not at all. Dr. Cooper was actually tasked by the United States Armed Forces to solve a massive logistical problem.
Oh, wow.
Yeah, the military needed a way to assess the cardiovascular endurance of huge groups of soldiers quickly and effectively.
Because they couldn't just, put 10,000 recruits on individual treadmills with oxygen masks.
Exactly. So Cooper devised a premise that was brutally simple. He basically said, just tell a soldier to run as far as they possibly can in exactly 12 minutes.
Which, 12 minutes sounds incredibly short when we were talking about long-distance endurance. Why not an hour? Or why not a fixed distance like a 5-kilometer race?
Well, that 12-minute window is actually highly intentional biology. In the world of exercise physiology, any run over 3 kilometers is considered a long-distance run.
Okay.
By forcing someone to run as hard as they can for 12 minutes, you are pushing them right into the sweet spot where they're practically guaranteed to rely on their aerobic energy system.
Ah, I see.
You are targeting their red, slow oxidative muscle cells rather than their short-term sprinting systems, which burn out in a matter of seconds or, a couple of minutes.
Let's talk about the actual metrics you get from this, because looking at the scoring charts from the original data, the numbers are humbling.
They really are.
If you are a 20 to 29-year-old male, an excellent score means you are covering over 2,800 meters in those 12 minutes.
Right.
For a female in that same age bracket, excellent is over 2,700 meters.
Which is a very aggressive, sustained pace.
Yeah.
But the scale becomes almost unbelievable when you look at the category for experienced athletes.
This genuinely blew my mind. For experienced athletes, the bar for excellent jumps to over 3,700 meters for men and over 3,000 meters for women.
It's staggering.
Think about that. Running 3,700 meters in 12 minutes means you are absolutely flying. It's practically a sustained sprint.
It really is.
But from what I read in the sources, you can't just go out to your local neighborhood park, map out a route on your phone, and do this test if you want a medically accurate result.
No, standardization is everything in physiological testing. For the data to mean anything, the environment has to be perfectly controlled.
So what are the rules?
Well, the Cooper test requires an ambient temperature between 50 and 75 degrees Fahrenheit with a maximum of 75% humidity.
Wow, that's specific.
Yes, and it specifically calls for a standard 400-meter tartan track.
That's the bouncy synthetic rubber surface you see at high schools and colleges,
Yeah,
right?
exactly. You cannot have elevation changes, mud, wind resistance, or extreme heat skewing the results.
Because all this very specific suffering isn't just to see how tough you are.
No.
There's an actual mathematical formula tied directly to the distance. The distance you run is just a variable in an equation to estimate your VO₂ max.
Right.
The formula from the original publication takes your distance in meters, minus 504.9, and divides that total by 44.73. Run the numbers, and boom, you have a solid, highly accurate estimate of your maximal oxygen uptake.
What's fascinating here is that the Cooper test was never really about the distance itself.
Really?
Yeah, I mean, the military didn't care if a soldier could run exactly 2,500 meters. The distance was merely a proxy for that golden metric VO₂ max.
Which is what exactly?
VO₂ max is the absolute highest rate at which your body can consume oxygen. It is the defining biological ceiling of your cardiovascular fitness.
But despite how brilliant this proxy was, the test actually fell out of favor in a lot of areas over the years.
It did. Logistically, it turned into a complete nightmare for the very people it was designed for.
I can imagine. Trying to perfectly track exactly where every single person is when a whistle blows sounds chaotic.
Imagine having 300 soldiers on a track. At the 12-minute mark, the whistle blows, and they all just stop.
Right.
Some are halfway through a turn, some are on the straightaway. An instructor has to manually figure out the exact fractional distance each person covered.
That sounds awful.
It proved much easier to just give them a fixed distance and time them as they cross a singular finish line.
Oh, that makes so much sense.
Yeah, that is why the U.S. Army eventually shifted to a 2-mile run, the Marines use a 3-mile run, and the British Army uses a 1.5-mile run.
And it wasn't just the military that moved on. Football referees, soccer, for our American listeners, used to live and die by the Cooper test.
They did. The English Football Association used it constantly.
But they phased it out for something called the HI intensity fitness test.
Right.
Because if you think about a real football match, a referee does not jog at a steady pace for 12 minutes.
So they stand still, they jog backward, they sprint at full speed to catch up to a breakaway play, and then they stop again.
Yeah, the Cooper test just didn't translate to the real-world demands of their specific sport.
Which highlights a fundamental truth about endurance. Pacing is a skill entirely separate from raw biological capacity.
Running for 12 minutes sounds simple on paper, but it's basically a 12-minute exam where your grade depends on sprinting the entire time. Pacing it perfectly is a nightmare.
It really is. Go too fast in minute 1 and your muscles flood with acidic byproducts, forcing you to walk by minute 4.
Which is the perfect bridge into the University of New Mexico research.
Yeah.
Because if pacing perfectly is what maximizes your score, it makes you wonder what invisible biological wall you were actually hitting when you go too fast.
Right, like what's actually failing.
Exactly. Why do my legs feel like lead? Why can't I just breathe faster and push through it? The Cooper test measures VO₂ max, but what is physically happening inside my body that puts a hard cap on that number?
To answer that, we have to look at the two fundamental requirements for endurance: consuming enough oxygen and having enough fuel to regenerate ATP.
ATP being the universal energy molecule in your cells, right?
Yes.
Yeah.
It is the currency your muscles use to contract. Without it, the muscle literally cannot function.
Let's start with the oxygen part. The University of New Mexico research divides oxygen consumption into two categories: central limitations and peripheral limitations.
Okay, so central limitations are all about the delivery system.
Meaning the heart and the blood.
Exactly. The dominant factor here is your cardiac output, which is just a math equation. It's your heart rate multiplied by your stroke volume.
And stroke volume is the actual physical amount of blood your heart pushes out with every single beat.
Yes, and this is where the body's ability to adapt is just incredible.
Because endurance training doesn't just make your heart beat faster, does it?
No, it fundamentally alters the physical structure of the organ. Over time, with consistent endurance training, the left ventricle of the heart undergoes physical remodeling.
The left ventricle is the main chamber responsible for pumping the oxygenated blood, right?
Right.
Yep.
It increases in chamber size, and the walls of the muscle actually become thicker.
Wow.
It literally stretches more, fills with a larger volume of blood, and pumps more fluid per beat.
So it's a bigger, stronger pump.
Yes. This is why elite endurance athletes have terrifyingly low resting heart rates. Their stroke volume is so massive, they simply don't need to beat as often to sustain their body.
But a bigger pump is useless if it doesn't have enough fluid to push around. The blood itself has to change too, right?
And it does. Your total blood volume increases significantly.
How does that happen?
Well, when you subject your body to the stress of endurance training, it responds by retaining more water to help regulate core temperature and blood pressure.
Okay.
This expands your blood plasma volume. Now, you also get an increase in red blood cells, but because the watery plasma increases so much, your blood's overall viscosity actually drops.
Now it gets thinner.
It gets slightly thinner, yes. And that reduced viscosity is a massive advantage because it allows the blood to flow much more easily through the incredibly tiny microscopic vessels in your muscles.
So what does this all mean? Let's try to build an analogy here. It sounds like a biological supply chain.
Oh, I like that.
If oxygen is the product we need, the heart and the blood are the delivery trucks driving on the highway. That is our central delivery system.
That's perfect.
Yeah.
And if the heart and blood are the delivery trucks, then the muscles are the factories receiving the goods.
Right.
And that brings us to the peripheral limitations, the extraction system.
Okay, so the trucks arrive at the factory. What happens next?
Well, the oxygen has to get from the blood into the actual muscle tissue. Endurance training builds more off-ramps for those trucks.
Off-ramps.
Yeah, it increases your papillary density by about 20%. You are literally growing more tiny blood vessels wrapped around your muscle fibers.
That is wild.
But the real magic, the actual processing of the oxygen, happens inside the cells in the mitochondria.
The powerhouse of the cell. I think that's the one thing everyone remembers from high school biology.
It is a cliche because it is absolutely true. The mitochondria are the microscopic furnaces where oxygen is used to produce that ATP currency we talked about.
And training changes them?
Drastically. With chronic endurance training, the size and the number of your mitochondria can increase by 50 to 100%.
Wait, really? You can double them?
Yes. Furthermore, the specialized enzymes inside the mitochondria that facilitate this chemical reaction can also double in quantity.
So you are basically expanding the factory floor, adding 100 new furnaces, and doubling the workforce to process the oxygen faster.
Exactly. You are building massive infrastructure to consume the oxygen delivered by the trucks.
That is amazing.
But here is the catch, and this addresses your earlier question about why you hit an invisible wall. Oxygen isn't enough on its own.
Right. You mentioned fuel.
A furnace needs a spark, but it also needs wood. You need a substrate, a physical fuel source, to burn alongside the oxygen.
And this brings us to the infamous concept of hitting the wall. The moment a runner just completely shuts down.
Exactly. Fuel supply inside the body is highly dependent on how hard you're pushing.
Okay, break that down for me.
When you are exercising at a low conversational intensity, say, below 60% of your VO₂ max, your body primarily burns fat.
And we have a lot of fat.
Right. For the purposes of a single exercise session, even the leanest athlete has an almost unlimited supply of fat to burn.
But you can't run a fast marathon at 60% effort. You have to push harder.
And the moment your intensity rises above 70% of your VO₂ max, your body shifts its fuel preference.
To what?
It starts burning carbohydrates, specifically glycogen stored directly in your muscles.
Why does it switch?
It does this because glycogen is much faster and more efficient to metabolize than fat when you need immediate energy. The problem is that your glycogen storage tank is very small.
How small are we talking?
After about 2 hours of intense, steady-state exercise, your muscle glycogen simply depletes. It is gone.
Oh, wow. 2 hours.
And when that happens, it does not matter how thick your left ventricle is or how much oxygen your delivery trucks are dropping off at the factory.
The furnaces have no wood.
Exactly. The muscle literally cannot regenerate ATP fast enough to sustain the contraction. You hit the wall.
Which is when people just collapse or start walking.
Yes. You experience profound muscular pain, deep fatigue, and you are forced to slow down to a pace where your body can switch back to burning fat.
That is fascinating. It is a hard...
Precisely.
And we also have to acknowledge that some people just start with a better supply chain, right? The UNM research points out that 10 to 30% of the variability in VO₂ max is completely governed by your parents. It's genetics.
The genetic lottery is a massive factor.
Yeah.
The genetic effect on your cardiac output, your heart's potential to grow and pump, can be up to 50%.
That is huge.
Plus, your ratio of muscle fibers is largely baked in at birth. Elite marathoners have been found to have over 90% slow-twitch muscle fibers in their legs.
Which means they are genetically predisposed to have massive mitochondrial capacity.
Exactly.
So we have this beautifully complex supply chain. The trucks and the factories.
Right.
And exercise physiologists have spent decades debating which side of this chain actually limits us the most.
They really have.
Like, if I want to be an elite runner, do I need a bigger heart or do I need better mitochondria?
It is the ultimate chicken or egg debate in sports science. But recent research has started to pull ahead with an answer.
Which is what leads us to the 2022 study.
Yes. Specifically, the 2022 study we are looking at today shows that the delivery trucks, meaning the sheer volume of blood and its oxygen-carrying capacity, might be the ultimate trump card that dictates human limits.
And this transition forces us to look at one of the most widely accepted, seemingly unbreakable facts in sports physiology, the gender gap in endurance.
Historically, the data has been very clear on this.
Right.
If you take a man and a woman of a similar training status, say two recreational runners or two elite Olympians, the man will, on average, have a 15 to 25% higher VO2 peak.
And this gap has been documented across every tier of athletics for decades.
Yes, it has.
But the why has always been a bit muddy. I feel like people just assumed men had intrinsically superior hearts or that male muscle fibers were somehow mechanically better at extracting oxygen.
Which is exactly the assumption the researchers in this 2022 study from Frontiers in Physiology wanted to challenge.
Okay, so what did they ask?
They asked a brilliant foundational question. Is this 15 to 25% performance gap due to intrinsic structural differences in the male heart and the male muscle factories? Or is it literally just a matter of the blood delivery trucks?
And the methodology they used to figure this out sounds like something out of a science fiction movie.
It is incredibly clever science.
So what did they do?
They took a group of healthy young men and meticulously matched their baseline physical activity levels to a group of healthy young women.
Okay, so evenly matched fitness levels.
Once they had these evenly matched groups, they decided to artificially equalize their blood.
Wait, equalize their blood?
Yes. They wanted to give the men the exact same blood volume and oxygen-carrying capacity as the women.
Wait, hold on. How do you artificially lower a man's blood volume to perfectly match a woman's?
By physically removing it.
You're kidding.
No, they placed a standard high-V line, a venflon, right in the crease of the elbow into the median cubital vein, and they safely withdrew a highly specific amount of blood from the men just before they did the exercise testing on the bikes.
Wow. How much blood?
It was roughly 8.1 milliliters per kilogram of body weight. To put that in perspective, it is slightly more than what you would give during a standard blood donation at the Red Cross.
Okay, so you bleed them a little bit to match the overall volume of fluid.
Right.
But men also naturally have higher hemoglobin levels. Hemoglobin is the actual protein in the red blood cell that carries the oxygen.
Correct.
So even with less blood, their remaining blood is still packing more oxygen. How did they solve that?
This is where it gets ingenious. To lower the oxygen carrying capacity, they use something called carbon monoxide rebreathing.
Carbon monoxide. Isn't that poison?
In high doses, absolutely, because of how it works. Carbon monoxide has an affinity for hemoglobin that is roughly 200 times stronger than oxygen.
Wow, 200 times.
It is like superglue. If CO binds to a hemoglobin molecule, oxygen simply cannot attach to it.
Oh, I see.
So by having the men rebreathe a microscopic, precisely calculated amount of carbon monoxide, they effectively locked up a specific percentage of their hemoglobin.
Oh, wow. So the hemoglobin is still physically there in the blood, but it's completely useless for the test.
Exactly. They temporarily deactivated enough hemoglobin so that the men's active, effective oxygen carrying capacity was lowered to perfectly match the female participants' baseline levels.
Okay, so the playing field is entirely leveled. The delivery trucks are exactly the same.
Yes.
The men now have the same volume of fluid and the same amount of functional oxygen writing in that fluid as the women. What happened when they actually put them on the exercise bikes?
The results were staggering. When the blood was equalized, that historic 19% sex gap in VO2 peak was completely abolished.
Completely. Just gone.
Gone. There was no statistically significant difference in their maximum oxygen uptake.
That is insane.
But even more importantly, the differences in cardiac output and stroke volume during the intense exercise also vanished when scaled to body size.
Really?
Yes, once the blood volume was matched, the male heart did not show any superior pumping mechanics compared to the female heart.
Here's where it gets really interesting. Wait, so you're telling me the male biological advantage in endurance isn't some magical, superior heart structure?
No, it's not.
It's not better muscle mechanics. It literally just comes down to the fact that men walk around with a higher volume of thick, oxygen-rich blood.
That is precisely what the data shows in healthy young individuals.
Right.
The performance gap is not intrinsic to the physical structure of the heart's pump. It is entirely dependent on the fluid being pumped.
That completely shatters how we usually talk about athletic differences.
But the study found something else.
There's more.
Yes. While they were analyzing the peripheral side of the supply chain, the muscle factories, they discovered a counterintuitive twist.
Okay, I'm listening.
The researchers noted that the young women actually have superior intrinsic mitochondrial respiration compared to the men.
Wait, I want to make sure I'm understanding this. The women's factories are actually better.
Yes. When they analyzed the skeletal muscle, the women showed greater mitochondrial content and a higher capacity to process oxygen within those cells.
Wow.
Their microscopic factories are actually more efficient than the men's.
That's incredible.
If we connect this to the bigger picture, the biological implications are profound. Because women actually have superior cellular machinery at the muscle level, imagine a scenario where their blood delivery trucks were magically equalized to men's.
They would win.
Exactly. If a woman naturally had the larger blood volume and higher hemoglobin concentration of a man, she might actually outperform him in endurance events.
Because of the factories.
Yes. Her superior mitochondrial metabolism would take over and process that oxygen faster. This study proves that not every part of the biological chain favors men.
Right.
The gap isn't a structural failing of the female body. It is just a highly specific variable in the circulatory fluid.
That is absolutely wild. It completely changes how I view the human body.
It really is a paradigm shift.
Next time you step onto a treadmill or you lace up your shoes to hit the track, I want you to remember this deep dive.
You really should.
You aren't just moving your legs. You are actively forcing the left ventricle of your heart to stretch and remodel itself.
You're multiplying the microscopic mitochondria inside your muscle fibers, building new factories.
Exactly. You are relying on your blood plasma volume to act as the ultimate biological delivery service.
And you now understand exactly what is happening under the hood when your lungs start to burn and you start to feel fatigued.
You aren't just tired. Your supply chain is reaching its absolute physical limit.
This raises an important question, something really fascinating to think about.
What's that?
If our baseline endurance and energy levels are so heavily dictated by our blood volume and our oxygen carrying capacity, and we know that endurance training directly increases both of those things over time, what if we stopped viewing cardio purely as a chore to lose weight or burn calories?
Oh, I see where you're going with this.
What if the ultimate life hack for having more energy to just get through a stressful workday or play with your kids without getting winded is intentionally training to expand your blood plasma volume?
You are literally building more delivery trucks for your everyday life.
Exactly.
That is an incredible reframing. You're not just getting fitter. You are fundamentally upgrading your body's internal plumbing to handle life better.
And hopefully pushing that cellular failure a little further down the road.
Next time you're grimacing at mile 20, just remember, it's not poetry. It's plasma. Thank you so much for joining us on this deep dive.
Until next time, keep exploring.